Hi guys, for this video, I will discuss the relationship between Kirchhoff's voltage law and current law. I'll demonstrate how to solve a circuit using this method. Okay, let's examine this circuit. The first action in solving it involves formulating the KVL equation. Initially, we need to identify the specific points within the circuit. Next step is to assume the direction of current flowing in each of the resistors. The current flowing to R1 will enter the junction here, which is referred to as I1. The voltage drop across R1 will be designated as VR1. Since the conventional flow of current is from positive to negative, the polarity will be from positive to negative. Then next for R2, the current flows away from the junction, to be called I2, and the voltage drop is referred to as VR2. The polarity is assigned from positive to negative. For R3 guys, it will be assumed that current flows entering the junction, and called I3. This will create a voltage drop referred to as VR3, and the polarity is from positive to negative. Just remember the conventional flow of current when designating the polarity of voltage drops. Guys, in this circuit we will take the loop ABEFA and BCDEB. Initially, we take the loop ABEFA. So the summation of all voltages in a loop is 0. Positive V1, since its ending polarity here with respect to its loop is positive. Minus VR1, because the ending polarity here is negative. And also minus VR2, since it is also negative here. That equates to 0. Since voltage drop is equal to I times R, then we will have V1 minus I1, R1 minus I2, R2 equals to 0. Using the values 20 minus I1 times 10 minus I2 times 5 equals 0. 20 minus 10, I1 minus 5, I2 equals 0. Subtracting both sides with 20. 20 minus 20 will be cancelled out. Then here it will be negative 20. Multiplying the equation with negative 1 over 5, to simplify the equation. So, 2I1 plus I2 equals 4. This will be our equation 1. Then now, we consider the loop BCDEB. So here it will be positive VR2, because the ending polarity here is positive. Plus VR3, because it is also positive. And minus V2, since here it is negative. Then it will be equated to 0. Again, voltage drop is equal to I times R, so positive I2, R2, plus I3, R3, minus V2 equal to 0. Using values I2 times 5, plus I3 times 6, minus 30 equals 0. Five I2 plus 6 I3 minus 30 equals to 0. Adding both sides with positive 30. So here, negative 30 plus 30 will be cancelled out. And here, it will be positive 30. So 5i2 plus 6i3 equals to 30. And this will be our equation 2. We already have these two KVL equations, now we will write our KCL equation. So in this circuit we have a junction here. Summation of all current in a junction is equal to 0. If you will write that in an equation, it will be I1 plus I2 plus I3 is equal to 0. Then we now consider the polarity based on the direction of the current. All the current entering the junction will be positive, and all the current leaving the junction will be negative. I1 will be positive, since it is entering the junction. I2 is negative, because it is leaving the junction. And I3 is positive since it also enters the junction. Then we equate this to I3, will be equal to I2 minus I1. This will serve as our third equation. Using the equation 2 and 3. (5i2 plus 6 times, open and close parenthesis I2 minus I1 equals 30. 5i2, then multiply 6 on I2 and on negative I1, so 6i2 minus 6i1 equals 30. Adding similar terms, so 5 plus 6 will be 11i2, minus 6i1 equals 30. Adding both sides with positive 6i1. So here it will be cancelled out. 11i2 equals 30 plus 6i1. Dividing both sides by 11. I2 is equal to 30 plus 6i1 all over 11. Then use this to equation number 1. So 2i1 plus the value of I2 here, which is 30 plus 6i1 all over 11 then equals to 4. Multiplying 11 on both sides. 22i1 plus 30 plus 6i1 equals to 44. Adding similar terms, 28i1 equals to 14. Dividing both sides by 28. Then I1 will be equal to 0.5 amperes. Using the value of I1 in equation 1. 2 times 0.5 plus I2 equals 4. 2 times 0.5 is 1. So I2 will be equal to 3 amperes. Lastly, using the values of I1 and I2 to equation 3. 3 minus 0.5 which is equal to 2.5 amperes. So that's it guys, that's how we solve a circuit using Kirchhoff's law.